Hello, my dear students. Now, there is another very important lecture that we are heading towards. That is the physical structure, the topologies of a network, how that works, and what is the reality of the network structures, why it has to be structured, and what is the attributes and characteristics of the different type of topologies and physical structures of the network. In previous lectures, we have came to know the network is known as the interconnection between the devices, the connecting devices. So there is a physical structures. First of all, the common type of connection is point to point and point to multi-point. As you can see, the point to point connection means there is a single link behind two devices. But if there is a mainframe computer or a server, give a single link and multiple users are going to add on this link, that is known as multi-point. Now, my dear students, we will go through to the next part. That's a very important part. It's known as physical topology. What is physical topology? Physical topology refers to the way in which a network is laid out physically. That means the way of connecting, the way of connection between them. Two or more devices connect to a link. Two or more links from a topology. The topology of a network is the geometric representation of the relationship of all the links and linking devices, usually called nodes, to one another. So that's the definition of the topology. That means that is a geometric representation of the relationship of all the links and linking devices with each other, and each of the linking devices is known as the nodes. There are four basic topologies right there: mesh topology, star topology, bus topology, and ring topology. You can see it or you can visualize it by the geometrical shape itself. But if anybody asks you why you would say topology, what is the physical topology? That refers to the way in which a network is laid out physically, how it has been interconnected to each other. Two or more devices connect to a link, two or more links from a topology. That means two or more devices, multi-point. We have just know on the previous slide. Just get to know on the previous slide. There's a point-to-point connection, point-to-multi-point connection. The two or more devices connect to a link, two or more links form a topology. These two or more links that form a topology. How that has been connected, the geometrical representation. Four or more important topologies. That is the mesh, star, bus, and ring. Okay. Now heading towards the type of the topology, that's a mesh topology. I can make you very much clear. You need not to just carry on those sentences that has been written here. Just one thing is that mesh means each of the every nodes, each node has connected to other nodes. There are no single connection, there are multiple connections, but if that is node number 1, this node number 1 is connected to 2, 3, 4 and 5. As you can see, that is the 1, that is the 1 to 3, that is the 1 to 4, that is the 1 to 5 connection, right? 1 to 2 connection, 1 to 3 connection. So there is a single point that has been connected to the multi-point part. Okay, 1 to 2, 1 to 3, 1 to 4, 1 to 5. Similarly, if you select number 2, you can see that from 2 to 1, from 2 to 3, from 2 to 4, and 2 to 5. And if you select 3, you can see 3 to 1, 3 to 2, 3 to 4, and 3 to 5. Each and every nodes has been connected to each other. Okay, so every other node, every other node. They are connected to every other node. There are no particular dimensions behind that. Just if you just take the number one node, that has been connected to all other four. If you take two, that will be connected to all other four. If you take three, all other four. That makes the mesh topology. That is known as mesh topology. Okay, and in mesh topology all the devices are fully connected. Okay, what are the advantages of the mesh topology? The first advantage, the use of dedicated links guarantees that each connection can carry out data load, thus eliminating the traffic problems that can occur when links must be shared by multiple devices. First of all, if a single node is connected to all the four other nodes with a single connection, point to point node with every multi-point, so they have a dedicated link, right? They have a dedicated links, so it guarantees the connection can carry out own data load. It should not be shared. It will be just point to point connections with every part. A mesh topology is a robust. Yes, it's robust. If one link becomes unusable, it does not incapacitate this entire system. That means if I just cut this point, it will not cut down other points. That will this will run. This will run clearly. They will run clearly. Or if you just cut this, the other four will run clearly. The other four connections will run clearly because there are not interconnection between these two. So we need not to think about it. Lastly, when every message travels along a dedicated line, only the intended recipient sees it. Physical boundaries prevent other users from gaining access to messages. That means it is a high security. No other unauthorized connection will get any chance to enter this kind of topology section. The point-to-point links make fault identification and fault isolation easy. As it is a point-to-point connection, if any type of link has have any kind of damage or any kind of problem, that it's not connected or not connected, we can determine it. And traffic can be routed avoid links with suspected problems. This facility enables the network manager to discover the precise location of the fault and aids in finding its cause. That means they can identify where the fault really occurs. Go through the disadvantage part. Disadvantage of a mesh are related to the amount of cabling because every device must be connected to every other device. Installation and reconnection are difficult. Though it is a robust design, but also it has a main disadvantage, that is the cabling, that will raise the cost. Secondly, the sheer bulk of the wiring can be greater than the available space. In walls, ceilings, poles can accommodate. Finally, the hardware required to connect each link, input-output ports, and cable can be prohibitively expensive, that I have told you before. For these reasons, a mesh topology is usually implemented in limited fashion. For example, as a backbone connecting main computers of a hybrid network that can be include several other topologies. You can say if you use a PC, personal computer, desktop PC, right, in your home, you connect your CPU with that, you connect your mouse, you connect your keyboard, and all. If you connect the printer, so each and every part has been connected to the single CPU. The monitor, the printer, the keyboard, the mouse, has been connected to a single source, that is the CPU. That's the one-to-one connections. So these kind of things in a similar fashion you can use the mesh topology, right? Okay. Now we will go through to the next part.